I skip the share for the Wikipedia about the binomial distribution. Well, after that one, we will have the continuous one. Well, up to now, geometry, binomial, person, these are well-known distribution, and they are frequently mentioned, at least mentioned. It doesn't mean frequently utilized, but if we want to pick one of the frequently utilized one, we will use person, that's correct. Geometry, that's possible as well. As for binomial, sometimes we will use it. And after that, we switch from discrete to continuous one. And then the most common used one is normal. Normal sometimes we call Gaussian. Normal or Gaussian, and we will have the specific distribution. Well, to have the story about distribution about normal, this one, maybe some reason so that we can reach this. And actually, you can treat it as a formula. And this formula is the symmetric distribution about its mean. So this is mean. And we will have the spread to be controlled by sigma. Sigma square is variance of normal, but sigma we will have another meaning, standard deviation. You can look up deviation. Deviation means we will have the difference from the central, actually from the central of the value. So deviation, that says we will have the difference. And this one we call standard deviation. Previously we have the sigma square, but this time we take the root of sigma square so that we can reduce to sigma itself. And this one we call it's the standard deviation. All right, so not really easy to tell why we will have a formula like this, and also this formula can associate with a bell shape like this. Bell. Yeah, that's correct. Bell. Bell shape. 中型. A bell shape like this. Well, I just don't know, and actually no specific reason why we have a form like this. And likewise, you can use binomial and wiki, and so that you can find the shape for the current distribution. Well, actually, before that one, normal, we should have a simple but common one, uniform. Uniform says from a specific point A to another point B. In between the 2 points, then we will have the same level of probability. And this way we call uniform. So then we just find a value for in between A and B. And what's the probability? The probability actually equal to this. This is 1, and this is B minus A. Sorry, B minus A. And this is CDF if we are asked to have a CDF. And CDF here, in fact, we have the relationship. Given PDF, can you have the relation for CDF? Yes. Right? Let me try this. So we have this. So this is relationship to have this one. But CDF actually we have this. Right? And you can try to follow the relationship. You will understand CDF actually it should be this formula. Right? Lower than A, we will have a 0 total because no probability. But beyond A, fall within A and B, then we will have the formula. Right? Through integral, then we will have an area. Area x minus A multiply this. So area should be x with x minus A multiply this. So of course we will have this result, right? And once we go beyond B, so what is the probability? Total probability 1, so that says we will have 1. Here I use the integral by collecting the area. Then it will be easier to know the formula. And to know the area 0, to know the area 1, and if we have a point x for in between A and B, how to find the area so that we carry out the integral. It's x minus A multiply the height. The height is 1 over B minus A. So of course it should be this, right? Okay, so if you understand this, I just want to emphasize we can have the relationship this one. Therefore, given PDF, you can try to find CDF. And likewise, given CDF, you can find through differentiation, you will find this, right? But we don't have the derivation for PDF, but we can have the derivation for CDF. And next popular one, it should be exponential. And there is no share for exponential here. Actually, exponential decay, not exponential growth. Alright, because we have a minus here. So it's exponential decay, not exponential growth. Alright, so the formula for exponential, normally we will use a form like this. Not negative 1. Not negative. And we will have 0 if we have the range for negative part. So non-negative part, we will follow the formula, this one. And likewise, you can have the derivation. So how to derive it, you can try. And the exponential, why a form like this? In fact, you can follow from exponential to raised power to minus x. But you can try to scale, and so we will have a scalar lambda here. And a scalar lambda here, actually we will have some meaning. For example, a scalar here, lambda, we will have 1 over lambda to denote its mean. You can try to follow the formula to find its mean. And actually, the answer should be this one, 1 over lambda. You can try. You can try, the answer should be 1 over lambda. So that 1 over lambda is the mean of exponential. Look at this one, right? And you can check it further. How about balance? Balance, you can find second moment. And second moment minus square of mean, so that you can have the results here. But I skip the derivation for this. You can try exponential. And that's